this week is payday. So, which isn't today, but it's this week. So, sometime next week. I know I was saying this week, but something came up, and I'm going to be taking a few PTO days off. Which if you don't know what PTO is, it's personal time off. Okay. I hate acronyms with a passion, guys. I really do. Especially when I'm reading. Okay, when I'm reading, if you ever read anything that I wrote technically, okay, you would know that I don't use acronyms. Okay, all right. Now, if and here's the thing, okay, what books do is they'll they'll say the word, okay, and we'll say the word Cisco, okay, all right, and then in parentheses they'll put a C for the acronym, okay, and never again for the rest of the entire book, okay, or documentation will they use the word Cisco spelled out. It will always be C, okay. I hate that. Okay, I hate it with a passion. Okay, and in fact, I have to actually write the word out on a piece of paper. So every time I see that acronym, I have to go back to my piece of paper, okay, and actually say the words out, okay, for what each letter of that acronym stands for, okay, every time I read it, and do not use the acronym, okay, because the acronyms are pointless, guys, without knowing what the hell they stand for. Okay, so I'm a big admin about it. Okay, and some acronyms, dude, it's just like, you know what? That's just ridiculous. Okay, all right, that's like 4 letters for each word, and you couldn't write that out. You had to make an acronym for it. What the hell? Okay, and not to mention the fact it's 2 words, and you make like a 3 to 4 word acronym for it. It's like, guys, the laziness in that aspect is ridiculous. Okay, so especially like words that you should not need an acronym for. All right, but I digress. So nonetheless, next topic. Okay, all right. So now, because labs are on hold, okay, this makes it a very long list of things that we have to go back and lab for. Okay, I guess from that perspective, because I've never done it this way. Like I said, I would talk about the theory and then lab it right after the theory. Okay, I've never done theory, then labs. Okay, and that's what we're doing here, and it is what it is. Okay, maybe I will actually make subsections like for well, what was the last video? I think 75, 075, and maybe I'll do like 075A. Okay, so you guys can actually, or 075L for lab, or dash L for labs, I guess. I don't know. We'll cross that bridge when it comes. But nonetheless. Alright. Hsrp. And my dumbass didn't even write out what the hell that stands for. Okay, so let's go find this here. Cisco. Okay, here we go. I don't know why I did that, but hey. And it's funny because I just talked about how serious it is with the acronyms. Okay, that's what's funny. Okay, so let's... No. I hate when I do that. Not control. Shift, buddy. Shift. Okay. Alright, let's right click. And we need to change that. Okay, because that's kind of getting redundant and monotonous. All right, and where is that? File. Oh, you know what? I'm gonna have to. Cause where's my option section? Okay, I guess I gotta figure that out later. Alright, and what I'm trying to do is change the default font size, because right now it is it is set to 11, and I can't believe I haven't changed it yet, and I can't believe I can't find the actions or the preference section. I just don't see it, and that's just nuts. Okay. What did they hide the options section? All right, but nonetheless, okay, we got it up here. So hot swap, hot standby router protocol. Okay, so now let's bring up our trusty thing here, so we can actually try to get better drawings with actual objects and circles instead of. Okay, you know, it really would be nice. Oh, oops. It really would be nice if I could copy and paste. And of course, now I can't select. There's no mouse option. Okay, so that's just weird. So you know what? Screw this. Close. No, because video doesn't work. I don't have a choice. All right, so Alright, so just forget it. Alright, so now, if I actually pause this, yeah, I can't do that either. I'm trying to figure out a way of actually writing on the screen. I can't do it because of the text file here. I gotta figure that out too. Okay, so now, what we have here is 2 routers and a switch. Okay? And, alright, let us draw our cloud here. Okay, well that came out a lot better than I thought. And that's not something to brag about either. So let's go here and go here. Okay? Alright, so this is router 1 and this is router 2. Okay. Now, as traffic is coming out, okay, we need to make a decision. I don't know what the hell I was drawing there. We have to make a decision, okay, of who's going to be the default gateway, all right? Okay, because we can't have both routers as the default gateway, okay? Now, in this scenario, we have 2 entry or exit points, all right? Sorry, my nose is running again. And what we have to do is have a default gateway assigned to our DHCP scope to send out to PCs that are asking for IP addresses when they boot. Now, including the IP address subnet mask, they're also going to be getting a default gateway in their TCP/IP scheme, okay? And they're going to get it from DHCP. Now, if router 1 is the router that is the DHCP, okay? I'm sorry, if that's giving leased out through DHCP, okay? Which would be the proper term to say. That's fine. Everything works. Everything is dandy. Until router 1 fails, okay? When router 1 fails, router 2 is still available, but the only way, now you gotta understand something here, okay? All right, let's go back for a second. All right, sending out the actual router information from the DHCP scope, okay? All right, your PC is going to have to do an ARP request to get the actual ARP entry for the default gateway, okay? Now, let's say this subnet here, all right, is going to be 192.168.1.0 network. Okay, so now I have a default gateway of 192.168.1.0. I'm sorry, 1.1, which is this here. Okay, in order for PC 1 down here, which is the only PC we got, to actually be able to communicate with this interface or even send traffic to this interface and build an encapsulation before the data is sent out, it needs what? Source IP, destination IP, source MAC, destination MAC. And the destination MAC of the default gateway needs to be in the ARP table. Okay, so now router 1 dies. Okay, all right, and the ARP table is not going to change. Okay, all right, and the default gateway has already been assigned via THCP. Okay, so how do we send traffic to router 2? You can't. The only way to do this, okay, is to assign, okay, because what's going to happen is router 1's going to die. Everyone's going to bitch about, hey, I can't get to the internet. So someone's going to have to go back into the DHCP pool, okay, and change the default gateway, okay, to 192.168.1.2, or and now think about that, and have all the PCs reboot. All right, telling everybody through a massive email saying reboot your PCs, or just go to router 2's interface here, okay, and change it to 192.168.1.1, okay. But most likely a reboot would have to be done anyway, so the MAC address will actually be reinstabled, because I'm reestablished, because you gotta understand, all right, it's in the ARP table for every PC out there. Okay, now you can do an IP config release and then a IP config renew. Okay, but giving everyone that instruction, okay, it'd be better on just to reboot the PC. Okay, because sending out an email to give someone that instructions, okay, not everybody knows where the command line is or what it is, okay, and trying to get users to do something as simple as typing in commands doesn't pan out. Some are going to succeed, some are going to fail, and now your help desk tickets are going to highly increase, okay, all right, they're going to start getting phone calls left and right. I don't know how to do this, all right, so, but easy thing is just say, hey, we fixed the problem. Everyone needs to reboot their PCs, and you'll get back to the internet. Okay, but that's annoying, because once you fix router 1, okay, you're gonna make this IP address now 192.168.1.2 again, and this is the 1.1. Okay, so there is a manual process that needs to take place in order to fix the problem. Okay, it's feasible. Okay, all right, but you need someone to manually do this switchover. Okay, all right, and we want something a little better. So, Hsrp, hot swap. Hot standby. Now, what does hot mean? It means without turning anything off. Okay, if I have a hard drive that is hot swappable, that means I don't have to worry about the operating system freaking out, okay, once you pull a hard drive out, okay, or putting a new hard drive in the bay, okay. You're not gonna have some blue screen of death thing going on because you screwed with one of the input output ports by plugging something in. Okay, all right, nothing's going to get shorted. It's a hot swappable feature, meaning that you can switch out and put in hard drives anytime you want. Okay, assuming that you have it in a RAID setup and a hard drive has died and it needs to be replaced. Okay, so now hot swappable power supplies. Okay, that wasn't a thing at one time, but now we have dual power supplies. One dies, we pull it out, Okay, put a brand new one in, and now we have redundant power again. All right, nothing has to be shut off. Data is still flowing. Nobody knows you switched out the power supply. So, hot swappable router protocol is the ability of swapping out one router to another, okay, without having a change in or notice in the actual data being changed. Now, that means here's the thing. Okay, now Hsrp is Cisco proprietary. Okay. Now there's two other ones over here. VRRP. Okay. All right, which is an industry standard, and GLBP. Okay. All right. I can't remember if that is industry standard or not. But that's something I have to look up, and right now I'm not doing that right now. So you can do that on your own research. So now, okay, so all of these are going to work similar, okay, but the details are going to be in Hsrp, okay, and then we'll kind of go over the other two briefly. Okay, so now, what's going to happen is you're going to configure Hsrp on router 1 and on router 2. Okay? Now, these interfaces is where that configuration is going to happen. Okay? Meaning that this one and this one. Okay? So now, because of that, they must be on the same subnet. That's why we have router 1 and router 2, this interface is 192.168.1.1, and this is 1.2. Okay? And they're going to join and communicate with each other and form a relationship with each other. Okay? And now we're going to have what is called a virtual IP address. Okay? If I can spell it. All right? That virtual IP address is now going to be 192.168.1.3 because we're using 1 and 2. Okay, if we wanted to use 1, then we will make this one 2 and this one 3. Okay, but we're doing 1.3. Okay, and the moment that the relationship of Hsrp forms up, I can ping 192.168.1.3, this virtual IP address, and they will have a virtual MAC address. Okay? And here's the thing. Router 1 and router 2 will negotiate on who will be the active router and who will be the standby router. And all traffic goes to the virtual MAC and the virtual IP address. Okay? And the virtual IP address, okay, will always send the traffic to the active router of the pair. Okay? And from what I remember, I believe you can do up to 4 routers with Hsrp, but that, again, don't quote me on that. That technology, I mean, it's definitely that could be, those numbers could have changed. Okay? But the thing is, you have redundancy now. Okay? In your IP configuration, 192.168.1.3 is going to be your default gateway. Okay, in your ARP table is going to be this virtual MAC address that Hsrp communicates on. Okay, so it doesn't matter. Okay, you can actually go into the actual router, okay, router 2, and say, I want now this to be the active router by manually configuring it as active, and the switch over will switch over from active to passive. I'm sorry, router 1 will go from active to passive, and router 2 will go from passive to active, and nobody will know it. Okay? Alright? The switchover is because everyone's communicating with this IP address, not 1.1 or 1.2. So now your two routers have become one in a sense. So when one dies, the switch over is in milliseconds, okay? And in that milliseconds, no traffic, nobody's going to notice a traffic drop. And even if it was a noticeable drop, we're talking about one packet. If we were constantly doing a ping, we might lose a ping, okay? All right, and then the next one's going to pick right back up, all right? So that's what we call a failover, okay? Now, we can even have, because what if we lose traffic on this side of the link, okay? Now, on this side, it's very simple, all right? We lose it on this side. That's very simple. Hsrp is going to pick up on that failure and it'll automatically, okay, make router 2 the active router. No biggie, okay? Now, but what if the link going to the internet dies? That's where we call tracking, okay? So in Hsrp, we can track a particular address that sits on the actual internet. Again, we're going to use Google 8.8.8.8, okay? And and we are constantly tracking that interface, not the interface, that IP address. And once that fails, meaning we've lost network connectivity for whatever reason, okay, and we can't reach that 8.8.8.8, we automatically fail over from router 1 to router 2. Once again, giving us redundancy, okay? Once again, we don't have to do shit, okay? All right? Now, it kind of sucks that this happens without your acknowledgement, and you wouldn't know that it failed over unless you have something in place like an CCNP message saying, hey, you know, Hsrp failover, and the NOC picks it up, okay, logs in and realize that, okay, because once they log into router 2, they can still get to router 1 through this plane if it dies on this end, okay? If it dies on this end, going here, okay, all right, we can still get to router 1 from the internet aspect on this side. So we're still able to get to both devices, and if we can't, we still at least know that we have a failed router, okay? Because the router itself died. How can you get to it at all? You can't. You can't even get to the management plane. You can't even log into the device, even from router 2's perspective, okay? So now you have to call local support and have him go to the actual closet, be your eyes and ears, and figure out what needs to be done. Put a Cisco TAC order in, not a Cisco TAC, but well, technically, yeah, Cisco TAC, to have a new equipment delivered to you. All right, so that's how Hsrp works. Okay, now how the hell do we get this big ass dot, by the way? Okay, all right. So, now, Vrrp is an industry standard, meaning that you don't have to have Cisco devices to do this, and you can do this with Juniper devices, okay? All right, because it's an industry standard, all right? So that means if you're choosing a router and you want this feature, I can't imagine you being a network router from a perspective of manage routers and switches and not have a Vrrp if you're not Cisco. I just can't imagine that. But, okay, make sure that your router does this if this is something you want. Okay, now, Vrrp is just the same as far as commands are concerned, except the fact you're not saying Hsrp, you're saying Vrrp. Okay, so you can use Vrrp on Cisco devices as well, okay, and you should be able to use them interchangeably with multiple vendors, meaning I have Juniper on one side and Cisco on the other. They should communicate the same language, okay? All right? Now, the preempt command with VRP and SHRP, okay, what that means is, okay, because in a active and standby, okay, or like VRP says, master and standby, okay, however you want to look at it, active standby, master standby, okay, the active router is the active router, period. But during the failover, router 2 becomes the active router. The preempt says, look, this router 1 needs to be preempt. And what that means that once router 1 comes back, it's going to take back the role of active. And router 1 is always going to be active as long as the links in itself is alive. Okay? Alright? And router 2 will always be the backup. And if router 2 becomes active, something's going on with router 1. Okay? If you don't put the preempt in there, router 2 becomes active and stays active until router 2 fails, whether the link or the actual hardware. And router 1 will never become the active again until there's a failover. Okay? Or unless you manually go through it and do it. Okay? So now, virtual IP can be the same as a router's interface. Set the priority to 255. I have no idea why that's written, and I'm gonna leave that alone. Virtual IP can be the same. Oh, okay. All right. So with SHRP, okay, the virtual IP is never the IP address of the interface. Okay. This is saying that virtual IP, which I would never do, by the way, never. But apparently you could do this with VRP and have the virtual IP address the same as a router's interface. And it says set priority to 255, and it cannot be changed. I'm not sure what that is either. So it's been a long time since I've done VRP from the perspective, because most of the time when I'm working, it's on Cisco devices. So usually we're using SHRP. I've only seen it once configured with VRP on a Cisco router, and it had no reason for it. It's just that's what that engineer chose to do, and I mean, hey, who cares? So now, GLB, okay. All right, so GLBP, okay. All right, I gotta find the word. I cannot believe I don't have the. All right, so virtual router redundancy protocol is the name of that one, and now I gotta look this up. This is ridiculous. All right, so GLBP. Okay, Gateway Load Balancing Protocol. Copy. Oops. Tim, 10.5. Jeez. Okay. All right. So that's I have no idea why that's not there, but nonetheless. Okay. All right. So it's just like SHRP and VRP. Okay. All right. I don't know if it's a Cisco proprietary. Does it say it? Industry standard. Oh, it is just a proprietary. Okay, so good. So that is a good thing to know. So, meaning that should go up here. Cisco. Prior. Okay, all right. Let's just do it this way. because I'm not even trying to show you how bad my spelling is, which you can already see. All right, so now let's get rid of this. All right. I don't know why I do that all the time. I hit the control key and not the shift key. I mean, the shift key is like 3 times the size. I don't know why I keep doing it. So, 24. I can tell you what though, this Cyber PowerPC, its keyboard, oh my god, it sucks. It's a nice looking keyboard, and you know the colors are pretty nice as far as the bike lighting color. But holy crap, I need to get a new keyboard because it blows. I can't even type with it. It's that bad. Because the keys get stuck, and the enter key is the worst. The main key that you need to use, and it always gets stuck. And I don't mean like stuck like to the bottom. I mean you can't even push the damn thing. It's like a serious major force I need to use because the actual scrolling up and down when you push the key is not done right. And there's other keys that get stuck too, so it's horrible. So nonetheless, okay, all right. Now, this still uses a virtual IP address, okay, all right. And we're not going into this, all right, as far as the active virtual forwarder and gateways. I'm not talking about this technology in that mindset. We might lab it one day, but you know, the thing is this, okay. You can have multiple routers in your group of routers, and traffic will use both routers based on the virtual MAC address, sending traffic to multiple routers in your group. Okay? Meaning that you're not going to have just a regular standby router that is not moving, because you got to understand. And I guess I never said that before, but the standby router does not move traffic. Okay? Period. Alright? It literally, you're literally paying for a circuit to just sit there and idle. Okay? You know, gateway load balancing protocol utilizes multiple routers in that group so you can use all your circuits. Okay? So that's the benefit of it. Okay? Alright? And that's it. Those are your you can call them hot standby routers or virtual router redundancy protocol. But the bottom line is, okay, you now have serious redundancy for 2 or more routers, okay, with IP internet facing links to the internet, and you'll be able to actually have redundancy, okay, automatically when one fails, okay? And if you're not using this technology, okay, I have problems with you, okay? Because the bottom line is you should be promoting redundancy, because as an engineer, redundancy becomes one of your number one, not even just responsibility, but concern, okay? All right? And if you only have one internet circuit, you can't use the redundancy. All right? So, I mean, it is what it is. Your company doesn't want to pay for another link. That's just it. Okay? But did you place the argument on why another link brings your percentage of downtime to a 5.9? Okay? All right? Now, don't get me wrong. The ISP is going to give you most likely a 5.9 LSA. Okay? But it doesn't mean, all right, if you had 5.9s on circuit 1 and circuit 2, okay, what are the chances of both routers failing? Okay? So that redundancy gives you a higher percentage of having zero downtime. Okay? Now, in our life, we focus and we reach, and our goal is 100%. Okay? So, if we get 95%, and I'm talking about like changes or anything we're doing, okay? Alright, even design. If we get 95%, we've had a good day. Okay? We're human beings. We make mistakes. Alright? But if you don't shoot for 100%, you're never going to get close to that 95% a day in your life. All right? Does that make sense? All right? So now, be strong, be determined, be Cisco.